Okay, so in this video, we're going to talk about combined gas law. So in the previous videos, we've studied the gas laws, right? We have the Boyle's law, Charles' law, and Gay-Lussac's law. So we can actually combine them into one law. This is called the combined gas law.
Sir.
Okay, so this is best described by this formula P1V1 over T1 equals P2V2 T2. But the question is, how did we get this? So I will show you how to derive combined gas law. Now, there are a lot of ways on how to get this, but this is the only, this is one of the ways, okay? So let's start with the Boyle's law. So P1V1 equals P2V2. Now, what you want to do is to multiply this by the Charles law. Initial temperature and volume is multiplied to the initial P1V1 of the Boyle's law, same as the final part. Okay, so we will have this equation V1 over T1 times P1V1 is equal to P2V2 times V2 over T2. Now, following your basic algebra, right, this will give us P1V1 squared over T1 is equal to P2V2 squared over T2. So take note that V1 and V2 are squared. Next, you have to use the Gay-Lussac's law. Just multiply the P1 over T1 and P2 T2, P2 over T2 on each respective side. So this will make the pressure and temperature squared. Now, since everything is squared, you have to take the square root, and this will give us the P1V1 over T1 equals P2V2 over T2, which is the combined gas law. So it's very simple, right? So now let's try to solve some problems. Right, so before we go to the problems, know that we also have the Avogadro's law.
Okay. I'm genuinely already about to cry. Am I okay?
Okay, so we can also use the Avogadro's law. So when we use this, this will give us P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. Okay, now to give you some illustration, let's use this to compute some problems. So let's start with an easy one. 2.0 liters of gas is collected at 25 degrees Celsius and 745 millimeter mercury. What is the volume at STP? So to make things organized, I want to do it like this. So I'll do a table, then I'll start inserting the given. So we're looking for volume at STP, and we all know that at STP, the pressure is 760 millimeter mercury, and the temperature is 273.15 K. And since volume is missing, let's write this as X. Now in the given, it says here that pressure 1 or the initial pressure is 745 mmHg, the volume is 2 liters, and the temperature is 298.15 K. So again, I converted 25 degrees Celsius to Kelvin. Then I'm going to use the formula for the combined gas law, substituting all the details. So inserting all the given, we will have this equation. This will give us 4.99 something 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 equals 760x over 273.15. Now what you want to do is to multiply 273 to the other side and divide it to 760, isolating x. So solving for this, x will be 1.796135 something. Since all the given have three significant figures, the final answer will be 1.80 liters. So don't forget the unit. Now, let's have this. The pressure of 80.0 liters of nitrogen gas in a flexible container is decreased to one half its original pressure, and its absolute temperature is increased to double the original temperature. What is the new volume? So this sounds so complicated, right? Double, half. But now let's try to analyze it. Okay, so actually there are two ways on how to solve this problem. So let's do the first one. So again, we start with a table. and insert all the given. So since we're looking for the new volume, which is the final volume, or V2, let's make it X. Then V1 is 8.40 liters, right? There's no pressure, so I'll write here P1 as P1. And it says here that the pressure is decreased to 1/2 its original pressure. So again, this is our original pressure, right? And you want to divide this into 2. So P2 will be P1 over 2. So again, P2 is equal to P1 initial temperature. This is our original pressure. Now, its absolute temperature is increased to double the original temperature. So if we let our original temperature be T1, final temperature will be 2T1. Okay? Now let's apply the formula. Now insert all the given. This will give us P1 times 8.40 over T1 is equal to P1 over 2 times X over T21. Multiply 2T1 to the other side and T1 to the other side. Basically just cross multiply. This will give you this equation. Let's multiply 2 to both sides so that P1 over 2 will just be P1, okay? And now let's isolate X. Both sides have P1 and T1, right? You can cancel them out. So we will have this 2 times 2 times 8.40 is equal to X. So solving for X is 33.6 liters. Okay, so it follows the significant figures, so this will be the final answer. Now, let's discuss the other way in solving this.
My head.
What I want to do is to just made a dummy number that follows the given requirement. So I want to make P1 as 2 so that my P2 will be 1. Why? Because again, P2 is half or 1/2 its original pressure. So 2 divided by 2, this will give me 1, right? So for the volume, we have given that. So it's the same, 8.40 and X. And the temperature, if I let 1 as T1, T2 will become 2. Because again, the temperature is doubled. It's there, double the original temperature. So T2 will be 2. Now just substitute this or the given to the formula and solve for X. You will still get the same number, 33.6 liters. But make sure if you do this, you'll not get confused with the numbers. And make sure that it follows the requirement.
Kahit anong gawin nyo sa akin, patayin nyo pa ako, hindi ko makukompute yan.